Okay, the meeting is being recorded. Great. Well, good afternoon, everybody. It's sort of a rainy day here in Boston. It's been a rainy weekend, so hopefully, I hear it's beautiful and warm in Hawaii. I don't know what it is in Alaska, but it's probably nicer than what we have here today. So, welcome and thanks for coming. What we have on the screen right now are as an overview again of the 4 lectures that we're dedicating to the notion of epidemiology. And last week we started talking about various different types of study designs. We didn't cover all that, so that's what I'm going to do first is talk about 2 designs that we didn't mention last week. And then hopefully time will permit for getting into what is supposed to be the topic for today, is the relative merits of these different designs. Because what you should do when you design a study is weigh the different alternatives that you can consider for addressing a particular research question, and then choose the one that's best for you. And best is going to be determined by a number of different parameters, and we'll talk about those today. And whether we get to it or not, the next thing we'll be talking about is the idea of statistical analysis, at least thinking of a plan for what we'll be doing for the analysis of our data once we collect from our study. So that's what we're going to be talking about today. And let's see, I go here, page up. So first, let me go back last week and talk about the various study design options. And remember, I showed you this slide last week that says we epidemiologists have a number of different designs. These are probably the 4 major ones. Last week, we talked about cross-sectional studies, and we talked about cohort studies. I'm going to start by talking about a design that's not used that often anymore, but I think it's going to go through a renaissance in the next few years. You'll see more case control designs. And then I'm going to end up talking about experimental studies. And the next homework assignment will deal with an experimental study. So with that in mind, let's move on to just a review of what we talked about last week. Remember what a cohort study was, is you first enroll people who are at risk of developing an outcome. The outcome might be developing diabetes, so you'd enroll people who are not yet diagnosed with diabetes. You then follow those people over a period of time, year, 5 years, 10 years, to see who develops diabetes and who doesn't. And then basically what you're going to end up doing is comparing those outcomes in 2 groups of people, or at least 2 groups of people, which are defined by your risk factor of interest. So you might want to be comparing people who are Native Hawaiian by ancestry to people who are not Native Hawaiian. So your exposed group might be the Native Hawaiian population in your study. You'll be measuring say, the incidence of developing diabetes among them. And your comparison group might be people who are not Native Hawaiian. You'd be comparing the incidence of diabetes among them. That's what we were talking about last week. But now let's shift gears a bit and talk about 2 different study designs. The first one I want to talk about is the case control design. And as I said, this was a very popular design 20, 30 years ago. A lot of epidemiology was used basing the designs on these case control studies. Then probably when data became more available, retrospective cohort studies became much more popular, or prospective studies are still very popular. So these are not studies you see that often done primarily, but as I said, they probably are going to be used more often in the future, for reasons I'll explain when I go through our first example. So let me first talk about the big picture of a case control design. What it's going to do is compare not outcomes, but exposures in 2 groups of people. You're going to start out with people who already have your outcome of interest, say who already have diabetes. You're going to be comparing that usually of people who don't have that outcome, who say don't have diabetes. What you're going to be asking is about some previous risk factor status in both of those groups. So you might be asking that in the past, were you exposed to a particular diet? Did you eat spam a lot, for example? So your exposure of interest will be spam consumption, say 10 years ago, 20 years ago. You'll be asking about those dietary questions to 2 groups of people, those who currently have diabetes and maybe those who don't have diabetes. Or maybe your cases are people who are overweight overweight and your controls are people who are not overweight. And by far the biggest problem in these designs is to select who is going to be your comparison group, who is going to be your control group. And that is the biggest problem in case control studies, selecting an appropriate control group. And I'll explain why that is so in a few minutes. So here's some more big picture. Last week we talked about cohort studies. We talked about in cohort studies how you can measure the risk of developing an outcome, the risk of developing diabetes among, say, spam users and among non-spam users. And we talked about calculating measures like risk ratios or rate ratios when you compare the incidence of the outcome, the incidence of diabetes among the exposed people, the spam users, to the non-exposed people, the non-spam users. Well, mathematically, that type of study and that type of calculation can also be considered as doing two other calculations. You measure how common exposure was among the people who got the outcome, among the people who developed, say, diabetes. You compare it to how common the exposure was in the population that you started with, population at risk, the entire cohort study. And what the purpose of the controls are in a case control study is to estimate how common the exposure was in that population at risk, in that initial cohort study. Because this is a display that you might see when you have a cohort study. You have two groups of people, say those exposed to a spam diet, those in exposure positive people. And the non-exposed people would be those exposed to a non-spam diet. And what you'd be doing, for example, is you might have N1 people who are eating spam. A of them develop diabetes and B of them do not. So if you want, you can measure the incidence of disease among the spam users. A people getting diabetes out of N1 spam. So A divided by N1 is the risk, or the cumulative incidence of developing the outcome diabetes among the exposed people, among the people who were eating spam. We also have a non-exposed group. N0 people who are not eating spam, C of them develop diabetes, D of them do not. So C divided by N0 would be the risk of developing diabetes among the people who are not eating spam. And the risk ratio, if you remember, is the risk among the exposed people, A divided by N1, divided by the risk among the non-exposed people, divided by N0. But mathematically, this calculation of a risk ratio can be also calculated by doing the following. First, divide A by C, then divide that quotient by N1 over N0. Well, what is A divided by C? Well, the A plus C people are everyone who developed diabetes in your cohort study. When you divide A divided by C, what you're measuring is the odds being a spam user among all the people who develop diabetes. When you divide N1 over N0, what you're doing is looking at everybody who was in your original cohort study, the N1 plus N0 people. You're comparing the size of the spam group to the size of the non-spam group. So N1 divided by N0 is the odds of being a spam user among everybody who was in your cohort study. So another mathematically equivalent way of thinking what a risk ratio is, measuring how common exposure is among the people who get the outcome, A divided by C. That's the odds of being an exposed person, the odds of being a spam user among all the people who develop the disease. And we're comparing that to the odds of being a spam user among everybody in the entire population. So that's another way of thinking what a risk ratio is, and that's another way of designing studies to estimate risk ratios. So let me give you an example of a case control study. It's a study that was done way back in 1983. I use it every year as an example of what we call a nested case control study, because it was nested within a previously done cohort study. Actually, it was a previously done experimental study. A colleague of mine by the name of Walter Willett, who's a well-known nutritional epidemiologist, did this study back in 1983. What he had access to was frozen blood samples that were collected as part of a previously done study known as the Hypertension Detection and Follow-Up Program. That study was an experimental study to look at different ways to try to treat people who were suffering from high blood pressure, from hypertension. But as part of that hypertension study, they asked people if they could donate blood. If they did, they froze those bloods, and what Dr. Willett had was a freezer full of frozen bloods. And he was using that to answer increase your risk of developing cancer. Do people with low serum selenium levels have different rates of developing cancer than people who have, say, high serum selenium levels? So what Dr. Willett had was access to 4,000